Today we're taking a look at factoring trinomials by grouping. And in particular, the type of trinomials we're looking at today are of the form ax squared plus bx plus c. And we have an example written below our general form, which is 3x squared minus 7x plus 2. So we're going to go ahead and pick out our a, b, and c. Our a is the number attached to the x squared term, that's a 3. Our b is the number attached to the just x term, and that's a minus 7 here. And our c is the constant, that's what the c means essentially, or just the number that's sitting there being added or subtracted. Here it's being added, so it's a positive 2. So we have a, b, and c. Now, in order to factor this, we need to break this up like we did in the previous section so that we have 4 terms, and then we can do the factoring. And we're going to do this by breaking up this x term here in the middle. Now, I'm going to go ahead and show you the process because I think that's the best way to learn this. And what we need in order to engage in this process is we need to figure out what AC is and what our B is. We already know what our B is. It's negative 7. AC is A times C, not air conditioning. A times C, which here is 3 times 2, aka 6. And with our AC and our B, we now need to find something which multiplies to A times C and adds to B. That's what we're looking for here. We want to find 2 numbers which multiply to A times C and add to B. So in the context of this problem, we need to find 2 numbers which multiply to 6 and add to negative 7. And for the majority of these problems, you just need to look at the various factors of A and C, the whole number integer factors. Like 6, 6 can be evenly divided by 1 and 6, 1 times 6 is 6, and 2 and 3, 2 times 3 is 6. But you'll notice that 2 plus 3 is 5, and 1 plus 6 is 7. And what we're looking for is negative 7. Well, this particular problem already has one little thing you need to watch out for, which is since our B here is negative and our A times C is positive, what this means is that the factors of 6 actually both need to be negative. And as you recall, 6 times 1 is 6 and 6 plus 1 is 7. So if we do negative 6 times negative 1, it equals positive 6. And negative 6 plus negative 1 is actually a negative 7. So the factors that we're looking for are negative 6 and negative 1. And you might be saying, all right, well, that's fine and dandy. But what do we do with this? Well, we're going to disassemble the negative 7x. This is the reason why it was so important that they added up to be the b value of negative 7. Because what happens here is when we disassemble this, we still have our 3x squared, but now we have a minus 6x, a minus 1x, and plus 2 still. So notice, between these 2 steps, we have only rewritten our trinomial so that it now has 4 terms. The negative 7x is still here. It's just been split into 2 parts. Now what we need to do is we actually need to do the factoring. And we do the factoring by looking at the pairs of numbers like this. So I put them in parentheses. Don't take this to mean they're multiplied by each other. I'm just trying to visually separate them. So they're currently visually separated. We'll make this a little bit more of a we'll make these more of a straight line rather than parentheses, because that could be more confusing. But they're just separated right now. So I'm first going to look at the 3x squared and the minus 6x. And we need to figure out what do they share. So now I'm actually going to put some parentheses in. 3x and negative 6x. Well, you'll notice this one has x squared, which is 2x's, and this one has an x. So already we get to pull an x out. And this is something you have to watch out for. You will always end up factoring out at least one variable in one of the 2 things that you need to do some factoring with. In addition to that, if we look at the leading numbers, the coefficients on x squared and x, this one has a 3 and this one has a negative 6. 3 goes evenly into both 3 and negative 6. So I actually get to grab a whole 3 out of 3x squared and a 3 out of the negative 6x. So what's left over after we take out 3x? Well, from 3x squared, all that's left is an x. And from negative 6x, we're left with a minus 2. And if you're not certain if you've done this correctly, you can always validate this by distributing the 3x back through, and you'd see, okay, 3x times x, that's 3x squared. 3x times negative 2, that's negative 6x. Okay. Now let's look at our second set, and we need to figure out if there's anything we can factor out of negative 1x and 2. And this is something that is sort of just a rule that you're going to have to adhere to every time. But we always need to have our leading x right here be positive. It needs to be a positive. It doesn't necessarily have to be just x, but it needs to be positive, whatever it is. So that means that even though negative 1 and 2 don't really share any like factors that you'd think of, I'm still going to pull a negative 1 out of here. So that goes on the outside. And then in my parentheses, when I take a negative 1 off of x, we're just left with the x. And when I take a negative 2 out of or negative 1, excuse me, out of a plus 2, that flips this to being a minus 2. And once again, if you need to validate this, you can say, okay, negative 1 times x is negative 1x. Negative 1 times negative 2 is positive 2. All right, we're good. Now at this point, all that's left is to do one final step of factoring. And then we're done factoring this problem. And you'll notice x minus 2 and x minus 2 are both attached to these two separate terms. So that means we actually get to factor out the entirety of what's written in the parentheses here, x minus 2. So we pull our x minus 2 out, and what we're left with that x minus 2 was originally multiplying by is 3x. Remember, it was 3x times x minus 2, and minus 1. That minus 1 times x minus 2. And at this point, we have completely factored this problem. All right, we're going to take a look at a second example. And the second example will introduce another wrinkle, of course, because there's just practically seems like an unlimited number of wrinkles in these problems. This one, we begin with 4x squared minus 10x minus 14. Now, the wrinkle in this problem is actually that we need to do some pre-factoring on this. In particular, we're looking for the greatest common factor, or the GCF. And the greatest common factor is any number or variable or combination of the two, which everything that we're given in our initial trinomial shares. Now, you'll notice that we don't share any x's because this term doesn't have any x's. We have one x here and 2 here, but none here, so we can't factor out an x. But if we look at our numbers, though, we have a 4, a 10, and a negative 10 and a negative 14. All those numbers are even. So we can go ahead and factor out a 2 as our greatest common factor. And if we pull that 2 out, we divide the 2 out of the 4x squared, so it becomes 2x squared. Obviously, 2 times 2 is 4. So if we distributed that through, we'd still have 4x. Our negative 10 becomes a negative 5. 2 times negative 5 is negative 10, so that checks out. And then we have minus 7, because 2 times negative 7 is negative 14, obviously. So now at this point that we've taken out our greatest common factor, we now need to factor this in the same manner as before, which means we need our A, C, and our B. So our A, B, and C, and we're only looking inside of our parentheses now without our greatest common factor. Our A is 2, our B is negative 5, and our C is now a negative 7. So our A times C is going to be 2 times negative 7, which is negative 14, and our B is the negative 5. All right. Now what we need to do is we need to pick out the factors like we did up here that got us to negative 6 and negative 1. So we need to pick the things which multiply to AC and add to negative B. Now, since AC is a negative number, we're going to need a negative and a positive. But let's look at the things that actually add up to 14. And I'll just put them on a note off to the side. I should say that multiply to 14. We have 1 times 14, we have 2 times 7, and that's actually it. So there's not very many options here. And if we look at this, I would say, well, 1 times 14 there's no way I'm going to get a -5. Those two numbers are way too far apart to get a -5 when we add them together. But if we look at 2 and 7, you'd say, oh, hold on. 7 minus 2 is 5, so there's probably something here. And indeed, there is. In particular, if we look at this, the -5 is what we're trying to add to. So the bigger of our two would need to be the -1. So -7 plus 2 would bring us to a -5. So at this point, we found the factors that we need. They are 2 and -7. They multiply to -14. They add to -5. And I'll remind you that if you don't know what the factors are, a little bit of an exhaustive search might be in order. So you can find all the factors of A and C and then figure out which ones and how you need to combine them with signs to get your B. So at this point, we have 2 and -7. Now what we can do is we can split up our X term right here. So I'm going to lead. We're going to have our 2. I'm going to have 2x squared still. And then we're going to have minus 7x. And then we have plus 2x. And finally, minus 7. So as I'm sure you can see here, -7x and 2x add together to make -5x. So it checks out. These two things are equal, so we're good. But now we actually need to do the factoring. So we have our 2 on the outside still. Let's see, what do 2x squared and -7x share? Well, 2 and -7 are prime numbers, and so we don't have any number that they share. So all we get to pull out of here is an x. So we're left with 2x minus 7. And then over here, we have 2x minus 7, and they don't share anything at all either. And if they don't share anything, well, then the only thing we get to pull out is a 1. Because we can't pull anything out of the 2x and the minus 7 because 2x, well, we don't have x's on the 7, and 2 and 7, like I said before, are prime. But look at what's happened here. And this is just like the previous problem. This was what you're going to want to watch out for. Every time you do this, if you've done it correctly, you're going to end up with 2 sets of parentheses that have the same thing sitting here. In the previous problem, it was x minus 2. In this one, not quite as pretty, but it's 2x minus 7. And then we need to pull our 2x minus 7 factor out. So we have our 2 outside of our parentheses. We pull out 2x minus 7. And then our second parentheses is what's left. X plus 1. And with that, we have completely factored this. We have that 2 on the outside. We have the 2x minus 7. And we have the x plus 1. And if you really wanted to, that second set of parentheses is technically unnecessary. If we wanted to be really, really clean about this, we could simply write our answer like this. All right, now is your opportunity to check out looking for a couple of greatest common factors on your own and then trying to factor one of these problems.